Okay. So let's have actually not a review or maybe an overview of the parameters and thresholds that's related to the radio access network. So an overview of the RAN, I think this has been discussed a while ago. So actually the RAN is what we see in the field. It's our gateway in from the users going into the network. So lahat ng pag pumupunta kayo sa labas, yung nakita kayo ng cell sites, that's actually the radio access network. You will see the antennas, the towers, and the RAUs, the remote radio units, and the baseband units. So based from this picture, we can have all the uh, uh, theory that we can discuss in overview so that it can be used as a guide for our discussion later. So you will see here the antennas. So I think most of you would be familiar with how the antenna is a passive element in the system. So it's basically a transducer that converts the analog signal. Actually, it receives and it transmits the radio signal. So based from that, we can discuss here how it propagates. It's you can see here a diagram of or a representation of the propagation, and you have the main beam, you have the side lobes, and then you have the hub power points or the negative 3 dB points. Wherein it's a guide for because for us from for radio access network optimizer or specialist, this is very important for us because my goal or our goal as a specialist is to have the best quality or the best signal for our customer. So mahalaga sa amin na you get the strongest signal possible. So this is our guide how we plan the site. So basically lahat dapat ng user nasa main lobe, yeah? Because if a user falls on the side lobe, there would be some problems. Although it's still accessible, but we have KPIs or the key performance indicators to meet. So kailangan may targets kami like accessibility should be like 99%. Drop calls, walang magda-drop above 1%, mga ganong KPIs. So this is very important for us because ito yung unang-una dapat tingnan the physical layer. Tama ba ang planning? Tama ba ang coverage area? Wala bang nag-overlap or wala bang anong tawag nga doon? Dead spot. So yun yung pinaplano namin, yun yung ino-optimize. So yeah. And then yeah, an overview that we started from 1G analog to then 2G, and then we have 3G, 4G, 5G, and then we're going into the 6G. And you will notice na we are actually voice driven before. Masaya na tayo nakikipagtawagan. But now we ventured into or we evolved that they are all data driven na even for the calls we don't anymore use CS calls. I mean, we're all IP based now using Viber or Messenger, di ba? Pag tumatawag tayo, hindi na tayo tumatawag via number, we're calling via WhatsApp or all applications na merong possible IP calls na pwedeng gamitin. And then yeah, based from this also, we are planning sites, we're optimizing sites, and one key element of that is mobility. Unlike from the 0Gs before, we had the PSTN na yung telepono lang natin sa bahay. Pag umalis tayo ng bahay, wala na. So, we go to yung mga umabot pa ng mga panahon na yon na if we want to call o meet up tayo into something and then hindi pa siya nagpakita, hahanap ka ng payphone. But so they're all static. I mean, they're on in one place. So they don't move. So they are wired. So pag nalinyahan na yon, doon na yon. But now we're mobile. So we have to move. And actually people are using data, people are calling while on the bus, while on the train. and while walking, di ba? And we are all mobile now. So it's very, very important for the optimizers or for the planner na you can go to one point to another without interruption in the service. So, like for example, you have this one, the cell A and or site A, and you have the site B, and that when you move from site A going near site B, walang interruption. So you can see here. Let me show the pointer. Okay, you can see here in the graph the attenuation of the signal. So habang lumalayo ka, syempre, you're going away from the site. So yung signal from site A humihina and up to the point na it will drop you kung naka-engage ka pa with the service or you're still going with the call. So the idea is that before that point, you have to have that threshold that you can be handed over, or so we call it the hand of point, handed over to the next stronger signal or a next stronger site. So from this point, ipapasa ka niya from the one site, and then of course when you go near that site, your signal gets stronger, and so the interruption will not be there. So ito yung pinaka-basic na kailangan mangyari, na even if you move, you get the best possible signal or service quality. And then of course with the planning part, at first when an MNO or an operator is investing into a network, it has to determine if ano ba ang gusto kong iservan. Like for the Philippines, for example, um, clusters are being categorized in like rural area, urban area, and dense urban area. Why? Because it has something to do on how we plan the site-to-site distance or the nominal points kung saan ilalagay yung mga sites. So kung mapapansin nyo, if we go to away from Metro Manila, sites tends to be higher or taller. Makikita mo yung mga self what you call that, the self standing towers, yung mga four-legged towers, so matataas na sila, but the site distance are farther away, like 1 kilometer away from each other. And when you go inside Metro Manila, papasok ka na ng urban, you tend to see that the site needs to be near to each other because you have much dense clutter. May mga buildings ka na, may mga obstructions ka na, unlike in the rural areas. And then if you go to the CBDs, like for example in Metro Manila, usually the MNOs tag Ortigas, Binondo, Makati, BGC are dense urban areas na mas maliliit or mas malalapit yung site-to-site distance like this one. So this is basically an overview of the radio access network that would guide us later in the discussion. So let's go through measurements. So here you can see that in the radio access network, constant measurements are needed because why? We need to have feedback. So in any system, para maging close, para maging self-sustaining siya, you have to have like feedback. Parang the network needs to know where are you. The network needs to know okay ka pa ba? Okay? Para walang hiwalayan. Anyway, sorry. Joke lang. I mean, the network should know that your signal strength are okay. Okay ka pa ba? Para hindi ka bibitaw. Okay? Na forever kayo, more than 11 years. Parang ganon. So the network is actually measuring this basic measurements or indicators. Like for example, for the RSRP or the signal reference signal received power is basically your signal level. Malakas pa ba yung signal? Okay pa ba tayo? Okay? Wala ka bang ibang kinikita? Okay? So RSRQ is like synchronization reference signal quality. Masaya ka pa ba? Masaya pa ba yung UE mo? Okay? So hindi ba ako choppy na sa'yo? Parang ganyan. And then the signal to noise interference ratio is that mayroon bang interference? May iba bang third party? Parang ganon. So these are all are all indicators for the UEs. When I say UE, is user equipment, or basically in layman's term, the phone. So the phone is a computer. It's computing, it's an antenna, it's computing all this and then reporting back to the network so that it will know what to do with you. It will know decisions na i-hand over na ba kita, or lalakasan ko pa ba, or i-improve ko pa ba to para hindi kayo hindi bumitaw. So you still have the best possible um, service. So you have the RSRP, ulitin ko, you have the RSRP, the level, you have the RSRQ, the quality, and then signal to noise ratio, of course, in terms of the interference. So you will see in our line of work, of course, we have tools to measure. Okay. The phones, yeah, ito yung ginagawa ng phone. But of course, for us, human, we need to have like an interface to see what the phones are seeing. So we will see here, of course, you know the speed test. But the speed test will only tell you up to the point gaano ba siya kabilis, gaano ba yung latency niya, which is the ping. But we really don't know who is serving, ano na ba yung level, okay? Ano na ba yung quality, ano na ba yung interference. So we'll see here, for example, I think, oh, ano ba to? It's using Pilot Pioneer. There are a lot of measurement tools. You have TEMS, you have NEMO, and then, for example, this Pilot Pioneer. But they're all the same. They're actually translating yung mga messages sa phones, sa UEs, and then ginagawa niya ng visualization like this one. You will see here NR. From the previous topics, you will already know that NR is new radio, is the term used for 5G. You will see here that network type is ENBC. So this is, ano nga ibig sabihin ito? Basically, it's an NSA. I mean, later we will discuss it further, but currently, when they discuss 5G kasi, medyo na iba na siya with the 4G. So ang mangyayari niyan, if MNOs or operators gonna deploy 5G agad-agad as in a standalone 5G, medyo malaking masakit sa bulsa. So there is this option wherein you have non-standalone, wherein you can still use 4G kasi medyo, ewan ko kung bawi na ba ni na Tito MVP or ni Ramon Ang yung mga naggastos nila, but we still have to take advantage of the 4G. So, NSA non-standalone, yung 5G na natatamasa natin ngayon, if anyone here are using phones and you have 5G signal, know that you're actually using NSA. I'm not sure. I think there's this one operator when they have already deployed a 5G standalone. I cannot say which operator, but yeah, but majority in the Philippines is still NSA. And I think I have this project in New Zealand. They're still using NSA also. So I haven't seen much of people actually investing in the SA. But yeah, so ito lang ENDC. When you see it, you still see NSA. You have the band 78. What is band 78? I think this is 700 or yeah, I'm not sure. But yeah, so it show you anong frequency gamit niya o anong band. Yeah, you have the frequency ARCN. And then yeah, you can see here the signal, neg 68. So this is in dBm. And then you have the SINR, which is 23. This is a good signal. Okay. CQI is 13, good signal. PCI is, ito, PCI malalaman mo kung anong site to. So you have the database and then you will know which site. So basically here you can see sinong site ang sa-serve, anong network, anong band, anong signal, anong quality. And then you will see here the LTE also. Yeah. So because this is NSA, you have two legs. You have the 4G part, kumbaga parang nagahati. Some user control part are in the LTE and some are in the 5G. So this is the NSA. And then here you can see the primary cell and then you have the secondary cell. Okay. And then, ito yung mga messages. Ito yung mga messages na nagpapadala ng feedback to the network. Okay, ano to? Yeah, pinagalaw lang. Pero yeah, nagibago siya. So, know that the network is very dynamic. Yeah, makikita mo dito habang gumagalaw ka. Actually, kahit di ka gumagalaw, talagang malikot siya. But you have ranges. So, usually, ginagawa namin ng kulay, yung ranges. Like for green is an agreed upon color in the network, in the industry, na pag green is good. So basically what it's saying that you have a good signal. And because of this, you're getting 518 Mbps. And I have experienced 1 gigabit per 1 Gbps in one country. So it depends also on your pipe or on your backhaul. So yeah. So if you have good signal, yun lang. If you have good signal, uh, you have good service. So yeah, makaka-download ka na ng maraming pelikula. Okay, so let's discuss threshold, hysteresis, and time to trigger. As I discussed a while ago, um, one key element of a radio access network is mobility. So, and to have you mobile, we have to have constant feedback to the network. And with that feedback, you have to report back to the network what's happening. And what's your reporting? These are the part of the reports, the thresholds, hysteresis, and the time to trigger. So, kumbaga they are all numericals. So, there are formulas. So, pag sinabi niya na pag ang signal ko ganito, I fall below this, I need to do this. So it's like an else if statement. So generic example to explain how the event threshold control event triggering. So we're calling it event triggering. So there are events in the network na pag na-reach mo yung ganito, ganito ang mangyayari. Pag na-reach mo yung ganyan, ganito ang mangyayari. So event B1, so let's discuss. Maraming events eh. So event B1, it's IRAT or the Inter-Radio Access Technology. Neighbor becomes better than threshold. So if a neighbor become better than threshold, it can be either by RSRP or by the level or by the quality. So kasi minsan the level can be good but the quality is not. Okay? Kasi nga may interference. Kasi maganda yung signal pero may interference so pangit yung quality. Or pag pangit na yung level, pwede rin maganda pa yung quality because wala kang interferer. Okay? So it's not like pag pumangit to, papangit to. So depende. Kaya nga meron kanina yung mga measurements. We have to have those so that you can have a better what do you call this, decision. So in this graph, you will see the what do you call this? Ano ba to? These are RSRP, I think. Or yeah, we can also think that this is RSRQ. But for discussion's sake, let's see that this is RSRP. So you can see here that ito yung graph natin for the RSRP. Medyo malikot, yeah, because sabi ko nga when we're moving or even we're staying put, medyo magalaw yung signal because radio waves are medyo yun nga they're going and going to and going from sa atin. So we can see that you have the thresholds here. So you have the leaving level and then you have the entering level. Okay? And then you have the hysteresis kasi sometimes you can have the hysteresis so that you have like a buffer. So parang okay, parang ano lang 'yan eh, 'di ba pag traffic light you have the red, the orange and the green and you have the orange so that from green hindi ka agad full stop. Although in the Philippines it's different, but you have the green and then you have the orange so that you have time to slow down before a full stop. So parang ganun din. You have hysteresis to have that buffer. So for example, here you can see that you have this filtered measurement and then you have the leaving level here and then you have the entering level. So and then you have the time to trigger. I mean, since malikot nga yung signal, you have to have time. Kumbaga, sure ka na ba? Parang ganun ba? So Pag na-reach na yung level na yon, bibilangan ka, sure ka na ba? If you stay at that level, okay, we have to decide. And then you stay on that decision. And then you have, of course, for example, lumayo ka na sa site, humina na yung signal mo, and then not necessarily humina ang signal mo, you need to leave. You have to have the hysteresis and then the leaving level, and then you have the time, and then if it's indeed that level, iti-trigger niya na yung event. So, ito yung basic. Makikita mo to if you go further into radio access network optimization, ang daming ganitong mga sistema na ina-apply sa iba't ibang features, sa iba't ibang mga functionalities. Na ano. So, yep. Okay, yeah. Someone, yeah, the documents, yeah. You can see here, if you want to have if you want to have a light reading bago matulog, you can, yeah, read this. Are the values RSR used for both 4G, 5G? Do they have similar values of 4G, 5G? Yeah, these are the same term we use for 4G, actually. The RSRP, RSIQ, and SIN. Do they have similar values for 4G, 5G? Yeah, in terms of the dB, they are similar because you're using decibel system. But then, there's as what I experienced in the work, in 4G, 5G, the the what is good quality in 4G might not be in the 5G level, so it might be lower. So it depends on the network actually. But yeah, technically they're the same. Should be. You still have you have a different system, but in terms of the radio properties, they should be the same.